In today's lesson, it is kind of an introduction to dividing polynomials. We're going to have a few different lessons, long division, synthetic division, but we're going to start with some basics, just dividing polynomials by a monomial. And to start, I'm just going to review some properties of exponents. So starting out, a quotient of powers. Here's an example. So I will have just a fraction, 5x to the third, y to the 12th, 15, x to the 6th, and y to the 8th. So 5 over 15, that simplifies to just 1/3. And then if I look at my x's, this is where you can match up and cross off. So there would be 3 left over, and they'd be left over in the denominator. And then the y's, if you matched up and cross off, there would be 4 left over in the numerator. Okay, and just a reminder about negative exponents. If you have 3x to the power of -4, the 3 stays, but the x can go to the denominator and become positive. So 3 over x to the 4th. And then the last one, power of a quotient, 2x squared over y to the 4th, all to the 3rd. So all of these, that power 3 has to be applied to everything. So 2 to the 3rd is 8. And then we multiply exponents. So x to the 6th and y to the 12th. So in the first part, we're going to look at a polynomial and find a GCF in the terms, and then we're going to factor the GCF out. So 5x to the 5th plus 10x squared. So there's a GCF between 5 and 10, which is 5. So I'm going to take a 5 out. And then if you look, if all terms have an x, we're going to take an x out. But we also take out the smaller exponent as well, so x squared. And then to write what's left over, I want you just to imagine dividing both terms by 5x squared. So inside parentheses, I will have, so these 5's cancel, and then x to the 5th divided by x squared, subtract your exponent, so it's x to the 3rd. And then here, 10 divided by 5 is 2, and then these cancel. Okay, here's another example, 18x to the 3rd plus 6x squared minus 3x. So GCF between the coefficients would be 3, and then all 3 terms have an x, and the smallest degree is just x to the 1st. So we just have to divide a 3x from each term. So this will be, let me get black. Okay, so this will be 6x squared plus 2x squared divided by x is x, and then minus 1. Okay, last example, 4x to the 8th plus 2x to the 7th minus 8x to the 4th. So GCF of the coefficients would be 2. And then look at your exponents. I'm going to take out x to the 4th. Okay, so first term, if I divide it, I'll be left with 2x to the 4th. Second term, I'll just be left with x to the 3rd. And the last term is just minus 4. So there's just finding GCF and factoring out. Okay, and now I'm just going to do 3 examples of what it looks like when we're taking a polynomial and dividing it by a monomial. So first example, 3x squared y plus 6xy minus 9x squared y squared. There's my polynomial, and I'm dividing it by a single monomial, 3xy. Okay, so when you are dividing, when you have like an expression like this, a fraction, and you have addition and subtraction, you can only simplify if you're going to divide all terms by that denominator. So for example, like off to the right here, if you had x plus 5 over x, you can't just cross the x's out and say this equals 5. No, you can't do that. If you had x plus 5 over x, you could say x over x plus 5 over x. Okay, so that is what we're going to do. So 3x squared y, the first term, I will divide that by 3xy. The second term, 3xy divided by 3xy. So each term has to be divided by that monomial. Okay, so 3's cancel, y's cancel, I'm left with just an x. X cancels, y cancels, I'm left with just a 2. And then minus 3xy. So I'm going to rearrange this. So negative 3xy plus x plus 2. Okay, next example, negative 42x to the 6th plus 42x to the 4th minus 49x squared all over negative 7x to the 4th. Just like last time, you have to divide each individual term by your denominator. Okay, so for the first term, we'll have positive 6x squared, and then we're going to go to minus just 6 because those will cancel, and then minus this negative, so that will go to plus 7, and then here, because there are more exponents, more x's in the denominator, you're left with this. Which this could be rewritten as, we've got 6x squared minus 6 plus 7x to the power of negative 2. Usually we always convert our negative exponents to a fraction, but I would accept this as an answer for this lesson. Okay, last example. Why don't you pause the video, write it down, and try it on your own, see how you do. So there is the work, and then here are the two answers. One if you're writing your exponents as negative exponents, and here if you're converting them to fractions. So there's your full video on dividing polynomials by a monomial. Good luck.